Going to talk about three things today. Vertical asymptotes, horizontal asymptotes, and holes in the graph. So I want to talk about vertical asymptotes. Brianna, here's your exam. You can go take it. You should probably do it now. You can use your calculator on the whole thing. Please show all your work. Wherever you want. Learning lab, cafeteria, outside, wherever you want. Vertical asymptotes. Guys, there's a lot of talking going on for some reason. Let me start off with horizontal asymptotes. Horizontal asymptote. So horizontal asymptote is a line that is y equals a number. Thank you, Brianna. They're expecting you. Y equals a number. The number must be a finite number. That means it cannot be infinity. That's what a horizontal asymptote. That's how we represent it mathematically. It's a line, of course. But what does it mean? The horizontal asymptote is what line the function, and of course by function we mean y values. What line the function or the y values approach as x approaches plus or minus infinity. So, let me read what this means again, and I'll add in some explanation as we go along. So it says, what line does the function, remember anytime you say the function you mean the y values, so it's what does the y values, or what do the y values approach as x approaches plus or minus infinity? What's interesting is the use of the term x approaches plus or minus infinity. That is what connects horizontal asymptotes back to what we've been talking about, which are limits. Because it is asking what happens as x approaches plus or minus infinity. So what happens as x approaches infinity, and what happens as x approaches negative infinity. So the horizontal asymptote is just asking you to answer the question, the limit as x goes to infinity and the limit as x goes to negative infinity. Two questions to answer when thinking about horizontal asymptotes. Now, what do horizontal asymptotes look like in terms of the picture? So the picture looks like the following. So it looks something like this. So here's a line that the graph is approaching. So as x goes to infinity, the graph approaches y equals 4. That means y equals 4 is a horizontal asymptote. You could have one horizontal asymptote like this. Another option is you could have a picture that is the following. And have one asymptote, I'll move it up one second. One asymptote that both is approached on the positive infinity side and on the negative infinity side. So maybe this is like y equals 1. There's a horizontal asymptote. It could just be what happens at infinity. It could be what happens at negative infinity and positive infinity. And finally, you could also have this. In other words, you could approach y equals 3 on the positive side, and you could approach y equals -1 on the negative infinity side. In other words, you could have two horizontal asymptotes that are different, one from the positive infinity side, one from the negative infinity side. Any of these are possibilities. This one happens to have two horizontal asymptotes. This happens to have one. This happens to have one also. It does not matter. The key is what is happening at infinity, what is happening at negative infinity. Questions? I got the email. I'll take care of it. Another important thing to remember about asymptotes, and this is something that you have been instructed incorrectly in the past. So I'm going to be very clear about this. A graph can touch/cross an asymptote. You have been told incorrectly in the past. I can almost guarantee in the past they said you cannot touch an asymptote. That's incorrect. This is totally legal. Here the graph goes through this point, call it y equals, 2. But then when x goes to infinity, the graph approaches y equals 2. We care about, for horizontal asymptote perspective, what happens as we go to infinity, or what happens as we go to negative infinity. This does not matter for the horizontal asymptote. We only care about what is happening as x goes to infinity or x goes to negative infinity. So this example would have a horizontal asymptote at y equals 2, because that is what the graph approaches as x approaches 2. Questions? Okay. Now, let's take a look at how to actually evaluate these limits, how to actually find them, and we'll do these 3 problems here on the homework. And I'm only going to focus on, for these ones, and you all only have to focus on for these, just focus on finding the limit. You don't need to worry about vertical asymptotes for these. Vertical asymptotes, directions are a little bit misleading, so vertical asymptotes are not needed. And you'll see how I modeled these 3, and that will allow you to do the last 3. So let's model the first one. We have limit as x goes to infinity, 4x squared plus 50 over x cubed minus 85. The first thing with any limit, we've always said this for past few days, is you take this and plug it in. Take whatever you're putting the limit to and plug that in for x. So you'll get the following. What happened? Oh, I'm sorry. So here we have infinity squared times 4, that's just infinity, plus 50. We have infinity cubed, just infinity, minus 85. Infinity plus 50, infinity. Infinity minus 85, also infinity. When we get something like this, we need to think to ourselves, this is not indeterminate, not like the 0 over 0, but in some senses it is similar to that, in that you need to do something to change the function. Because we do not want infinity over infinity. We want to get something like a number. Like infinity over a number, or 3 over 5, or something like that. Yeah, so this was the interesting question asked in the previous class, and the reason it's not 1 is because, yes, these approach, both the numerator and denominator approach infinity, but they approach infinity at different speeds. What I mean by that is the following. If you plug in 100 to the top and 100 to the bottom is way bigger than the top. Does that make sense, Giselle? Because the bottom is 100 cubed and the top is only 100 squared. So although they do both go to infinity, this one is going to go there at a much quicker speed than the other one. So as a result, these don't actually equal 1 because A, these two never get to infinity, and B, they reach there at different speeds. Great question. Ron Beer asked the exact same question in the previous class. Now, what do we need to do in order to solve this out? What we need to do is, every time, divide by the highest exponent in the denominator. So the solution is, or the strategy, or the trick, whatever you want to call it, is to divide by the highest exponent in the denominator. So in this case, I'm going to divide everything by x cubed. So I'll get the following. Because x cubed is the biggest exponent downstairs. I'll get this. So we're going to divide each term by x cubed. So let's see what happens now. We've got limit. And if you divide everything by something, equation doesn't change. So this is going to become 4 over x plus 50 over x cubed divided by 1 minus 85 over x cubed. And now you are in a position to plug this in. Now you're in a position to plug in infinity. We get to here. And now what do we get? We have 4 over infinity, 0, 50 over infinity cubed, 0, 1 minus 85 over infinity cubed, 85 over infinity is 0, so we get 0 over 1, which equals 0. So now we'll say that the limit as x approaches infinity of 4x squared plus 50 over x cubed minus 85 equals 0. So, yeah, go ahead, Edgar.
Can you say what you did on the, when you divided by the
by x cubed?
Yes.
So, x cubed